thank you all for showing up at a workshop instead of just going to another talk. What we're going to do today is we're going to create an app that downloads movies from the movie DB and shows them in the app, and you can scroll through them and show the details of it. And we're going to do this in Flutter. A little bit about me. I'm an Android developer by profession. I like apps, software, and programming. We don't do Flutter in production. This is a side project for myself just to get to learn Flutter and see what it's about. Besides doing Android development, I help my wife run a food blog. I manage the technical part of it, trying to keep everything working with WordPress, which is a really interesting challenge if it starts to grow. Well, the fun about Flutter is it's written in Dart, and well, I'm a Star Wars fan, so I came up with this small meme. Well, let's start with the workshop. I've put the code on GitLab. You can get it from this repository. There's also a link in the slides, link to the slides in it, where you can get the API key. So I'll leave that up for a little bit. And if people have questions about it, you can just ask them whenever you get to the point or the step you are, and I'll try to answer them. Did everybody get the URL? I'm hearing nobody say yes, so I'll just leave it up. We also need to install Flutter. There's a link in the README, of course, but it points to here where you can download the SDK if you haven't installed it already. It's really easy to set up. And I'll continue to the next one. This is the API key. It's just a public service. And here's a little animation of the app we're going to make. It shows a list of the Star Wars movies. You can open the detail screen, show some additional information, share it with whoever you want if you like the movie. And yeah, we're using the movie DB and the developer documentation for the API you can also find over there. It's also linked in the steps and in the README. And that's it for the slides. This isn't really a presentation talk anyway, so we're going to do code. Seems I've broken Git. Okay. So we're basically gonna start in step one. Step one is setting up the project, adding the dependencies, and just querying the API. You can see the different steps. I've written everything out so you can follow at your own pace. But basically, we're going to create the basic app and get the JSON data from the API and put that into objects. So for Flutter to work fast on mobile, they decided to remove some parts of the Dart engine, namely reflection, and a lot of JSON parseling, JSON serializing libraries, they use reflection to automatically map to objects, which is kind of annoying if you want to do Flutter and you think, hey, I don't want to query and map directly. I want to have statically typed objects with correct types of everything. And then you would have to set it up yourself and write all the boilerplate code of mapping that to the values in the JSON. But luckily, there are third-party libraries that handle such a task for you. They generate code. So the first thing we're going to do, we're going to add a library that is in the PubSpec YAML, which is the package management and build system file where we configure the project. You can already see some dependencies you get. We have a dependencies block for the actual runtime of the application and a dependencies block for dependencies during development, which includes the test framework. And we want to add JSON annotation. And I'm gonna see here. Yeah. You can copy stuff from the steps if you don't want to type everything. JSON annotation is a library that adds an annotation to the project. I've already created some of the models that you get if you download the project, because the models aren't really that complex. It's just a plain old Dart object. It's a class, and it has fields with all the names of the JSON keys and the types, and a simple constructor, and a factory method where you can put in your map of the JSON, and it will create a object for you. And the parts that are highlighted as not found are the code that is going to get generated by the third-party libraries we're going to add. So we need to add a build runner library, which is a basic library that can generate Dart code for you. And the JSON serializable is the library that actually knows how to create serializable objects from JSON. And at the top, we see a toolbar saying we can get the packages, upgrade them, upgrade Flutter itself, see some logging about how the Flutter installation is on your machine. But basically, we just want to get the new packages we added and then that they are available through our project. If you run that, the Flutter build system will download them for you. And it will create a PubSpec log file, which basically logs all the versions at the moment you say get. If you don't have the file already, it will create a new one. If you have the file, it will download those specific dependencies that are defined here. So you can make reproducible builds every time you want to, and are not saying, okay, I want to have this version from this version up to the minor version, I think. And then if you reload the projects in the next few months, the version gets updated and something breaks. This is to prevent that. If you do Android development, there are plugins to also add that capabilities to Gradle, but basically we just have to specify the direct version in the Gradle file for Android, which also works, but a lot of other languages also use a log file to log those dependencies. Package gets, I think it already got downloaded. So what we want to do now is we want to generate the code for the objects we created. We do that by calling the Flutter SDK, and then calling the package component, package pop run build. All these commands are also in the steps, so you can easily copy them yourself. Build runner run. I should have copied it, of course. Pop spec has changed. Please run popget. Maybe I didn't run it yet. Okay, now it should have the dependencies. Build. Definitely should have copied it. What it's doing now, it's executing the build runner project or the build runner library, and it starts to create the code for us. And you will see it pop up in a second. Here we get a models.g.dart file, and in Dart, the g.dart is a naming thing to mark that a file is generated for you. As you can see, it's a lot of code that gets generated for you, and if you would have to write it yourself, it could be really boring. And it's also very simple code, just getting the map and matching that key to the field and then setting the value. But that allows us to no, it's referencing a static directly. A small error in the Git. So basically, I've already set up the project a bit to make it a bit more easier that we can start with code directly. What we want to do now is we want to download the JSON data from the API and then parse that to objects we already created. So I've already made some convenience methods that have the URL and the query parameters and the header set for you. And it calls the get movies search result with the URI. And we need to implement that method to download the JSON. So is everybody following so far, or am I going too fast? No? Okay. Basically, we want to do an HTTP request, and for that we need to add an additional library to do the actual request, and then also install that package, and then it should be added to the project. Flutter works in a way that you can do asynchronous code with an async await construction. So you don't have multiple threads that you can start up and do work on and then go back to another thread. This is more akin to the JavaScript async await or C# async await methods. And what we're going to do is we're going to create a method that does the HTTP request, and it's going to return a future of this object. So we know for certainty that at some point this object will be filled for us, but we don't know when. What we want to do is we want to import the HTTP package, and we can alias that to HTTP. Import. So now it says it's not used, so if you save it, it will automatically delete it. There it goes. And this provides us with an HTTP client where you can call on methods that all do the get, post, put, patch, and head HTTP methods. We're just going to do the get method because it's getting the JSON. Now I need to add the import again. So what this does, it calls the get method on the HTTP client. It passes in the URI, sets the headers, and then awaits for that method to process. And then once that's done, the value response gets set. And once we have that resource, it's a HTTP response. So you have a body, a status code, request headers, stuff like that. But we are interested in the body, of course. And the body is JSON, so we want to convert that JSON to a map in Dart. Import, which is available through the JSON decoder. You can just call that method. It's a framework-specific implementation. And you can pass it a string. And that converts that JSON to a map. Here you might notice the dynamic. Dynamic is a type which gets... you don't know what it is yet. It gets decided on runtime at the first time it gets called. And the special thing about Dart is also that this map can hold multiple types as a value. If you, for instance, would work with Java, you can also create a map, but that's typed to one value type. So you can't put an int and a string as value in the same map as their original types. You can either put a map of ints or a map of strings. And Dart provides a way of doing that by saying, hey, we don't know what the type is, so the moment we touch that code, it gets inferred by the system, and then we know what the type is. Once we have that map, if you wouldn't have created all that code for the JSON serialization, you could just directly work with that map and call a method or the key on it. For instance, title. And this should return a string for title. Of course, typing. But yeah, then we would be iterating over maps with just string-based and hope we typed the correct key and don't make mistakes with that. We don't even know if it's available or if it's in the map or not. So we want to use that map and create an object out of it. Movie search results collection. And we can call the factory method of that and pass it the actual map. And this will return a movie search result collection. What we are after, results return. So basically, this will return movie. Somewhere at the bottom, I know. This will return this object, which has a page number, total results, and total number of pages the API returns, and the actual movie results we want, which contain the title, the ID, maybe an image, stuff like that. So now that we've created the implementation for that method, we want to use it. And I'm just going to add it here for convenience sakes. API client is new API client. We need to import that library. Also, we can remove the new keyword in the latest version of Dart. They added that to make it a little bit less verbose. But basically now we have an API client that can call the API and return an object. Get movie search results. But if we call this, actually nothing happens because we don't know when the result is returned, and we can't do anything with it yet. So what Futures offers us are a few methods that you can apply on them, like then catch error when complete, that handle certain stages of the future. So we're going to use the then method, which returns a value of a movie search collection. And now we have that every time this code gets executed, when we get a result, then we get the value and we can do something with that value. So for now, we're going to print the titles of the movie in the log. Value results for each. So this code should call the API. When we get a response, print all the titles to the log. Let's see. Oh, no emulator running. Luckily, they're fast now, so it should boot up very fast. We're going to install the app. The nice thing about Flutter is during development, it creates an APK for us. And if we make changes in our code in the Flutter code base, it tries to hot reload that code in the running application. So doing changes on the UI or doing changes on logic can be very fast compared to doing it the native route on iOS or Android, where it needs to either recompile the whole app. With Insta-Run, it's getting better, but it still takes in the order of 10 to 15 seconds to recompile the app and then install it on the device. So basically, we have our running application, and it should trying to call. Oh, it seems to run into a snag. Convert the map. Let's see if this actually returns something. The nice thing about Flutter also is that debugging works out of the box. You don't have to set up anything out of the ordinary to get debugging running in your working in your application, and this works for both Android and iOS, so it doesn't matter which device you're running on. Invalid API key, of course. your API key here. Is it hard reloading now? As you can see, we did the request, and once we got it back, it started printing out the titles of the movie. We created an easy API client that returns a response for us, and now we want to use that response and start creating a UI for that. If we go to, just check if I didn't skip anything. Didn't skip anything. So everybody can keep up with this. Do you have questions? Ask them. No, okay. Then I'll just continue. So in the next step of our workshop, we're going to use that response that we created earlier, and we're going to create a grid view that shows us the titles of the movie. It isn't very exciting, but it's a basic it works thing. Let me change to that step. Disregard. Let's see if I know the git commands from the command line. Copy the force. Yeah. So once we go to step 2, the methods are already implemented because we already did that, so it's no point of letting you do that again. I'm going to add the API key to it again. So I'll explain a little bit about what's going to happen here. I didn't do that in the previous step because I just wanted to get the API request worked out first. When you create a Flutter app, there is a main entry point in that application, which is the void main. If you have done Java development, for instance, you have kind of noticed this pattern, which also has a static main to start the application. And in that method, we call runApp, which will run our app, and we pass it a widget. Almost everything in Flutter is a widget. It's a UI component that is easy to use. But in this sense, you can create a library, for instance, that is a widget, and somebody can just run that as an application, or you can insert another application into your own application because everything is a widget. Don't know why you would want to do that, but you can. The My App is the base widget. It's a stateless widget, which means that once it gets run, it doesn't change anymore. So all the values and all the state that is in this widget, it stays during the instantiation of that object. It doesn't change anymore. If you want to change it, it has to be recreated. So yeah, for the base of our application, we started once. It should stay the same during the entire run of the application. So we use a stateless widget. And a stateless widget has a method build, which is very similar to how React has its components with the render method, which gets executed and builds the UI for us. In this case, we pass it another widget called Material App to give our app a material theme and a material style. These are all platform widgets that are provided to us through Flutter. Yeah, we set up the theme, set the colors and the text style, and then we pass it a home page, which is the home screen that we're going to show in the app. In this case, it's also in this case, it's a stateful widget, which means this widget can be recreated with a new state, but the widget still keeps alive. And we have a state object to manage that state and redraw the widget. So the platform will call create state for us, which will return the state object. Same as a stateless widget, the state object has a build method where we do the actual creation of what we want to show in the UI, and you can put some logic based on the state. If there's a list, do this. If there's no list, show another widget. And you can decide how the UI component should look based on the state. As I mentioned, we created the get movie search results, and it uses a future to get the data and then return the data to it once it has awaited the HTTP request. But that can happen anytime. If you have slow network, it can take ages. But if this widget gets created, we don't want to be wiring up it ourselves, like, hey, recreate when the state changes. There is a widget for that. It's a very interesting widget. It's called a future builder, which you can give a type. For this future builder, we give it the type movie search results, and you can pass it the actual future that gets executed, and a builder method which gets a snapshot which has the state of that future. So depending on what the future is doing, we can return a different widget. For instance, we're loading something from the network, so during loading we want to show a loading spinner. And once the future completes, it will call the builder again, and it will pass in a different state so we can check what is the state now. Is it done? Does it have an error? If it has an error, show something else. If it has the actual result, we can show it as a list. And I've already set up a movie grid widget, which gets the list when we want. This should already work as an application, get dependencies, of course. See if we can have them next to each other. Yeah. So now we have an empty view, and we want to load a grid view widget when we have the data. If it's loading, we want to show a loading spinner. If we have an error, we want to show the error message. So this I'm just going to copy because it's a little bit more code. As I explained, the future builder, you pass in the future, and a builder method, and the snapshot has the state of the actual connection, and you can, well, create an if or a switch on it and then do your thing accordingly. I see the difference. There's a nice thing about Flutter. It tries to infer the type for you, but just for clarity's sake, I usually try to add it to make it more clear what is happening, and you don't have to go through all the code. Ah, nice. We have an error. But one of the cool things about Flutter, it doesn't crash your app. You usually, if you do native development, you have an error in your application, an null pointer exception, and the app will crash and give you a stack trace, and you try to fix it. But now, if we just, let's see, return text. It just reloads for us. It keeps the state, and it reloads the widget with the correct code. So here we want to return a loading state. So return, I can copy that up also. In Flutter, everything is a widget. So instead of having a UI components that have lots of properties to set the padding and all the alignment and stuff of a box, Flutter actually nests those components into each other. So here we have a center widget, which the only thing it does, it centers its children in the middle of it. And we have a column component which shows the children in a vertical way, and you also have a row component which shows them horizontally, and you have different kind of container widgets that can do stuff for you. But this makes it very easy to understand what happens to your UI if you just see the nesting of those components, versus if there's all kinds of properties and they can interact with each other also. This is all top-down from the top widget to the bottom widget, and they don't interfere with each other all the way up back again. Return. So, well, you saw it very quickly. If we open the app again. That's still something that happens if you are working with a hot reloaded app and you open it again. Sometimes it forgets that it got new code. But yeah, hopefully they are going to fix that. So I'm also already going to go to the next step. In the next part of the switch case, where the data actually should return, we need to check if there was a network error, or there was an error. It could be a network error, a timeout, or something like that. And yeah, if there's an error, show the error message, and else we'll just show a grid view. Basically what this code does, we have a grid view widget, which has a builder method where we pass in a delegate which decides the sizing of the children. So we specify that we want to have 2 columns, and the size of the items should be, I think, 65% of the screen. maybe a little bit less. And we pass in how many items this grid view is going to have, which is the same as the results we get back from the API. And of course, there is a builder method which gets called for every item in the list, where you get the index of the list, so you can operate on it. We're just going to show the title of the index of that item in a text view. So if I would load this now, it's going to create a list view. So it loaded our data, and as you see, we have a simple grid items, 2 columns, and they're the size of the screen, and you can scroll through the list. Well, app-wise, this isn't really exciting, but shows that it works and that we can easily create widgets based on futures. Flutter also offers the ability to use streams instead of futures. If you have, for instance, a WebSocket that continually gets data, you can use a stream to get continually updated once you get an update. And yeah, for that there's also a widget called Stream Builder. So in a sense, you can really easily create UI based on those concepts. So for the next step, we're going to make the application a bit nicer. We're going to show some images, spruce up the items a bit. Let me switch to it. Copy. So this is basically where we left off. I just extracted the grid view to its own separate class, so it should be easier to read, and also if you would want to reuse something like this, you can. This step already has the complete item. Let's see if this will run. API key, of course. Yeah, that's the same code. Yeah, I extracted the code a bit more, so it's a separate class. And instead of just using the method itself to create a new text item, we instantiate a movie item, pass it in the movie, a date format to format the date. And then here in this item, which extends the stateless widget, we use a gesture detector to wrap that widget so it can handle clicks or other gestures, like on long press or something else. You can even make your own gestures and detect them if you want to. Yeah, we wrap a card, and that card contains a image view and a footer which has the title and the date. Here we use a fade-in image, which keeps it in memory, and it tries to load it from the network. K-transparent image is a library because it's basically a transparent image that's in memory. It's just a byte array. There's also asset network. If you want to load an image asset, you could use that. But this is just from an empty state to the actual image. The image view works, simply pass it the URL and say how it should be sized. Here we're just fitting the height, so everything is nice and clean for the poster. But if you have other aspect ratios, you can fit weight or what do we have more? Yeah, scale down, cover, all the usual things you can do with images. And yeah, of course, we're not doing anything to handle null errors yet. We just check if it's null, not null, show the image, else just show a transparent image. But you can construct all kinds of way of how you want to handle that. Maybe make an image loader class that you just call every time instead of doing it directly in the widget you're using it. But that's up to you. That's one of the things that I think you need to learn when you start working with Flutter is how deeply nested do you want your widgets to be. It's always hard to find the right kind of abstraction in your code. It doesn't matter which framework you use. So basically now we have a grid view which loads the image and the text. And as you can see, all the images are now preloaded in memory. So if you scroll through it, it doesn't need to download them again. So if we go to step 4, so this should, here we're gonna start creating the next page in the application. So basically we have the entry page which shows the list, and now when somebody clicks the item, we want to go to the next page and then show details of that movie. Flutter works with a routing system, which you can predefine at compile time. So you can specify certain routes, which should be triggered when you call navigator and then pass in the route. So it can be kind of a URI-based structure, how you view make the views of the navigation of your application. But you can also dynamically create them in code and then just call that method. Here we have a material page router we're using because it's a material app. And depending on which platform you're running on, it will do the animation according to the platform. So on iOS, it will slide in from the right. And if you exit the screen, it will slide back to the right. And on Android, it will come from the bottom up and go back down from the bottom. And you can create your own animations for that, or you can create your own router if you want to do something different with that. But here we are just passing in the movie, and then we are returning a new widget. So I've already created the base page, which is a stateless widget. It gets passed in the movie. That doesn't change anymore after the widget gets created. And then it's going to show the movie information, or it should show the movie information. We create a custom scroll view because we want to add a header to the screen that if you scroll up, it will go out of the window. And if you want to, you could also add a title that will go to the app bar if you want. That's all provided by the Sliver app bar You pass in how high you want it to be, if it should be pinned. You pass in a widget, which is going to show the actual header. And then the next item in the list is a sliver list. Don't know why they call it sliver. It doesn't sound very nice when you say it out loud, but the sliver list will generate list items for your scroll view. So in our case, we're going to create a spec view which will show a poster, the title, the vote average, vote count. It will show the overview of the movie as text. So let's see what this looks like now. API key, of course. Really need to set up this workshop better. Get dependencies. Yeah. So nothing happens yet because we need to implement the on-tap handling. For that, we have a gesture detector, as I mentioned, with a argument on tap. You have multiple arguments, long press. What do we have more? If you look at the constructor, there are a lot of different gestures that it handles. And if you want to create your own gesture detector, you can even add your own gestures. For now, we're just using the on-tap. And here we call the navigator. Navigator dot push a new route. Basically, it needs the context of the widget and a route that needs to be pushed. Yeah, you could also use, if you set it up earlier, navigator and push named, then you can enter a route name or a string and do something with that. In this case, we're just gonna use this route of. We need to import it, of course. Only the movie. Yeah. So, yeah. Well, as you can see, now we have a black screen. Nothing happens, but it does open the new page. Basically, we have to start implement the new page with how we want it to look. We're going to do that in step 4. So we have this movie spec view. Now it doesn't show any thing yet because the header also doesn't do anything. I know what's happening. This is one of the issues with the hot reload still, that if you hot reload and you've changed in Git, it can get messed up. Let's see if rebuilding the app works. Okay. Well, then we just start to implement it. Here we want to show the image. I'll just copy that from the finished. So for the header image, we are using a stack widget, which just basically puts all the widgets on top of each other, layered in a Z with a Z index. We have added a decorated box with a gradient. So if you would have text there for the title, the back button, icons for the action icons, they are visible when it animates to a normal app bar from the image. So let's see if this does something. No. I think we need to have to implement everything for it. I'll just copy this file, make it easier, not edit, open raw. It's named differently. Seems Git has messed up. Okay. So this is one of the nice things about Dart. When you create methods, you can give them names, which is the name of the attribute. You can put them without names, and then they are really compile time required. Or you can do a positional way that they have a fixed position. So if you want to have multiple methods taking in different type of parameters versus, then you can do that instead of just creating overloads for methods. You can also give them a default value if you want, is hello. So now you can leave them empty, but because it's required, this is not going to work anyway. Which is a really interesting way if you're coming from Java, you're used to just overloading the method, adding new parameters, and calling the super method. If you're used to Kotlin, you do it like you can also do a bit like this with named parameters. I think I messed up the Git repo when I tried to push the steps in all the correct order this morning. But basically what it was going to show is, where do we have the... can just go to the finished. Copy. So I'll just explain the code from the finished concept. So, yeah, the endpoint is to show all the detail information, but yeah, the step was supposed to show a minimal information that you got from the search results, and then also do a new API query for the extra information you can get from the API, and then just loading that progressively when you get that in. So basically you would get the movie result, then have the future builder that listens to the future of get movie, which loads the movie data. And then first show the minimal data you have, and then load the full movie information. And basically these are just almost copies from each other, but they have more list items. So the minimal movie info only has the movie specs, the text overview, and a loading spinner. And then the full movie info also has a tagline, a reviews widget that shows the reviews you can get. And you have a share button where you can share the movie. This is a library which adds native parts to your project for iOS and Android to do actual sharing, and give you a convenience method to do that. I can also run this, for instance, on iOS. Let's wait for that to boot up. So what I did in the movie spec view is create a row widget. Oh, go back. A row widget, which is this part, which has two children, a poster, and a column which contains the title, which is also a column with a row with two children, and then it has a list of chips which are the genre. And yeah, it took me a while to figure out how to size everything correctly, because yeah, I'm also new to Flutter and I'm just used to Android layouts where you can specify that per properties. And this is a nested structure of, okay, now I change this, then the genres were moving out of the rest of the list. So it takes getting used to, but it is quite comprehensible when you start to learn it. So it is an interesting thing. And if you come from the web, you're probably used to it with Flexbox, because they use those constraint types to do the layouting. So it could be very familiar. Let's see. The iOS simulator has also started up. So we can run the exact same application on iOS. And as you see, the animation is going up from the bottom as per the material guidelines. And if you do that on iOS, it's going to be different. Yeah. So here you see it swipe in from the left. And also this screen now has the back gesture that if you're an iOS user you're familiar with. We didn't have to do anything for that. We get that out of the box because the components and the widgets are styled for the specific platform by the core team already. This doesn't have the back gesture. But let's see, I'm targeting. There's an interesting concept that you can do. Toggle widget mode, no. There used to be a button that you can change the runtime of your application. So if you just flip the switch, it would execute the iOS runtime for you, and then the app wouldn't even restart. Everything would be just iOS styled. That does show the power you can have with Flutter. You can go the whole platform route. A lot of the native widgets are almost pixel perfectly created for you by the core team, but you can also create your whole own branding style for it. If you have a larger brand and you have a design system, you can create that for your application or multiple applications. Also a nice thing is this has just been recently added to the developer tools, is that once the application is running, you get 3 of the widgets that are on the screen. And you can go to the code directly. And I thought there was also a possibility to highlight them in the actual running device, if you would select them. But here you can actually see the output of your code in the actual render tree while your app is running, which can be very convenient if you're trying to debug things. Yeah, I don't know if there are questions. Okay.
If there are questions, there are 2 microphones on the sides of the stage. So either I can come to you, or you can just go to the microphones on the side of the stage. Please ask some question if you have it. Yeah. And don't be afraid. We're here for that.
If nobody has a question, I'll have...
Hey, thanks for this. So here you've talked about Flutter as kind of a multi-platform development tool.
Yeah.
Why do you like Flutter over something like React Native or some of the other cross-platform tools?
Basically because of the integration for the developer tools. If you look at React Native, for instance, you have to do a lot of hassle to get that up and running and just get a debugger running on your device. You have to have the IDE installed, probably Chrome, connected the Chrome web developer tools, and then you can debug in the Chrome web developer tools while you're developing in another IDE. And yeah, I did that at my previous work. We tried to set that up, and the first thing you notice is you need to go through hoops to get things done. And what they are trying to do with Flutter is make the whole developer experience really easy for the developer if they want to start with Flutter, which I think is a major thing if you want to look at a new technology. It should be easy to use. Yeah, and also the concepts that they're trying to do, they have an opinion on how they want things to work, and they implement them that way. But Flutter is fully open source, so you can change everything you want. You can look all the way from the code you write in your application to the lowest level of C implementation, and either use the respective layer that you're looking at, or change it, or work with that. which I think is also very powerful. If you do Android, for instance, if you just download the SDK, open it in your Android Studio, there are no implementations of methods. You don't know what it's doing. You have to download the sources, then you can see some implementation, but still a lot of it is hidden behind layers and behind proprietary code. Or it's in the ASP repo, and then there's no match with your project. And the same goes for iOS. That's even more obscure because it's totally proprietary.